In this video, we're going to look at three methods to factor expressions. The first one is called factoring by reverse distribution or common factor. The second one, difference of two squares. The third one is factor trinomials. So the first objective number one, let's look at the expression given in part A, 4x minus 16. Now this is going to be done by what we call a reverse distribution. Now the distribution in algebra, it's a multiplied by b plus c, gives me ab plus ac. Now what we are going to do is reverse this and say ab plus ac is equal to ab plus c. So going from here to here, we have written our expression as a product. This is also called factoring by common factor. So let's look at what we have. We have 4x. Now, how do we find the common factor? 4x, we are going to write it as a factor. Now, 4, we are going to factor it using the prime numbers. The prime numbers, remember, are 2, 3, 5, 7, and so on. They are the numbers that have only two factors, 1 and itself. So 4x, 4, I'm going to write it as a factor of prime numbers, starting with the 2. 4 is 2 times 2, and then multiply by x. That's give me 4x. Good. Now 16. 16, it's a number, so I'm going to use prime numbers only. It's 2 times 8. 8 is 2 times 4. And 4 is 2 times 2. Good. Now we compare 4x and 16. Try to find all the common factors. 1 here, 1 here, 1 here, 1 here, and that's it. These are the common factors. So 2 multiplied by 2, 2 multiplied by 2, and this is common. This is called the greatest common factor, GCF, is equal to 4. So I go back to my expression. 4x is 4, my common factor multiplied by x. 16 is my common factor, 4 multiplied by 4. This is the common factor. I use the reverse distribution and I write it as 4x minus 4. Check. It's always easy to check factoring. 4 times x give me 4x. 4 times negative 4 give me minus 16, which is correct. Now let's look at the expression given in part B. So 6x2 and 2x. Now we start with 6x2. 6 as a product of prime numbers, it's 2 times 3. And that's it. We cannot do any more. And then we multiply by x to account for the x2. 2x is 2 multiplied by x. Now let's look at all the common factors. There is a 2 and there is the x. So the common factor, or the GCF, the greatest common factor is 2x. I go to my expressions and I start factoring. So 6x2, I put 2x multiplied by 3x. 2x multiplied by 1. Okay, let me explain. Now I need 2x to appear as a factor. So 6x2, 2x by 3x. Check. 6x2. 2x is 2x multiplied by 1 because, as remember, the common factor is going to be 2x. So I go here. This is my common factor. And there is nothing else to factor. So this is the complete factoring of the expression given in part 2. Now, objective number 2, we are going to use what we call factoring by using the difference of two squares. Now, let's start by the following. A plus b multiply by a minus b, that gives me a square, and then a by minus b, that gives me minus ab plus ba. Ab and ba is the same, that becomes 0, and then minus b square. So all this, the product, gives me the difference of two squares. Now I'm going to write it in reverse: a square minus b square. So if you have the difference of two squares, you can factor them as follows. Remember, factoring is writing an expression as a product. So a square minus b square is a plus b minus a minus b. Let's go to our expression. X2, we already have square. 9, we can write it as square 3 power 2. And then this has the form a square minus b square, so that will be x plus 3, x minus 3. This is the factoring of x2 minus 9. We can check as usual. This gives me my x2. This gives me minus 3x, and then this plus 3x, 0. And then 3 by minus 3, that gives me minus 3 square, minus outside, of course. Now we continue with part D, and now in part D we have 9x2, 16y2. So let's see if we can write this as the difference of two squares. 9x2 is equal, 9 is 3 power 2 by x2, and this can be written as 3x power 2. So this is a square. Now how about 16y2? 16 is 4 times 2, y2, and again this can be written as a square. So I go back to my expression and I substitute 9x2. Look, 9x2 by the square, 3x power 2. 16y2 is 4y power 2 square. And then I go and apply the formula above. So a is 3x and b is 4y, and that gives me 3x plus 4y multiply by 3x minus 4y. Again, we can check very quickly. 3x by 3x, 9x2, it's here. And then 3x by minus 4y, that gives you minus 12x, and then this gives you plus 12x, 0. 4y minus 4y minus 16y2. So the factoring is correct. Now let's look at objective number 3, which is factoring trinomials. Now a trinomial, it's an expression with with the degree 2, so it's of the form ax2 plus bx plus c. So how do we factor x2 minus 4x minus 5? Because of the x2, we need linear terms that when multiplied give us the expression, and we can see that this x multiplied by this x will give me the x2. But it's not finished, because we need the minus 4, the minus 5, and so on. So let's say this is x plus k, and this is x plus m. When we develop this, what do we get? We get the x2. And then x by m, that gives me mx. And then k by x, kx, or please kx. And then k by m, that gives me km. Good. Now let's do one more thing here. Let's factor the x outside. So that will be x m plus k plus km. So we want this polynomial to be equal to this. Now when we compare them, we have the x2, same coefficient, so there is no problem here. However, let's look at the coefficient of x here. It's minus 4. Here it's m plus k. Let's look at the constant term, minus 5. Here it's k multiplied by m. Okay, so we want this polynomial to be equal to this one. Therefore, their corresponding coefficient must be equal. The coefficient of x2 is 1, x2 is 1. Here minus 4x, m plus k, and so on. Now, how are we going to find m and k? We're going to do this by guessing. M, k. So let's find two numbers. When we multiply them, they give me minus 5. It's either minus 1 and 5 or 1 and minus 5. But when I add these two numbers, they have to give me minus 4. So it looks like this one here, because 1 plus minus 5, that gives me minus 4. So m equal to 1, k equal minus 5. Now I go to my factoring here. So x2 minus 4x minus 5 is equal to x plus k plus minus 5, that gives me this, and then x plus m, that gives me x plus m here. Now this, the answer, it will be here, so x minus 5 and x plus 1. Let's check. X multiplied by x, that gives me my x2. X multiplied by 1, that gives me plus x, and this gives me minus 5x, that gives me minus 4x, that's good. Minus 5 by plus 1 gives me minus 5, and this is my factoring for part E. Now, in part F, we also have a trinomial of degree 2, 3 terms, with the highest power is 2. And then we need to factor it. However, here we have got some fractions. The fraction is 1/2 here, 1/2 here, and maybe the best thing to do is to factor this half out. Now here we don't have half, so let's create 1. So my expression is 1x2. How can I write x with the half? So 1/2 of 2 gives me 1. Okay, so 1/2, and then the coefficient of x is 1. I write it as 1/2 multiplied by 2. That gives me 1. Good. So I go here, and I have the common factor half. So again, this is distribution in reverse. However, here we've got 3 terms. Now what we have inside is x2 plus 2x plus 1. Now let's see why. When now this is 1/2 x2, so I take the half out, I'm left with x2. This is 1/2 2x, so I'm left, when I take the half out, I'm left with 2x. And this is 1/2 multiplied by 1. When I take it out, I'm left with the 1. Okay, we haven't finished, because we still have another trinomial here now. So again, we use the same idea as in E. X here, and then we need 2 constant here and here. When we multiply them, so the product must give me 1, the sum must give me 2. And these numbers are just 1 and 1. 1 plus 1 gives me 2. 1 multiplied by 1 gives me 1. So x plus 1, x plus 1, and of course x plus 1 multiplied by x plus 1 can be even written in compact form as a square. And this is the factoring of the expression in part F. So we have seen three important objectives in factoring. Now, factoring, one way to learn factoring is to practice, practice, and practice. We learn by doing.